Yeah.
Visible ആണല്ലോ.
Visible.
Okay. Good morning, everyone. എൻ്റെ പേര് അരുൺ ആർനാഥ്. ഞാനിപ്പോൾ ഇൻട്രൊഡക്ഷൻ ടു റിമോട്ട് സെൻസിങ് ആൻഡ് ജിയോഗ്രാഫിക് ഇൻഫർമേഷൻ സിസ്റ്റം എന്നൊരു ഹോട്ട് ടോപ്പിക്കിനെ കുറിച്ച് ഒരു ബ്രീഫ് ഇൻട്രൊഡക്ടറി ക്ലാസ് അതാണ് ഈ ഒരു വെബിനാർ കൊണ്ട് നമ്മൾ ഉദ്ദേശിക്കുന്നത്. So, I think most of you have heard about remote sensing and GIS. It's right now it is like one of the hottest topic or a hottest tech in the world as well as in India. So, ഇപ്പോൾ നമ്മുടെ എല്ലാ domain platforms in public sector as well as private sector ഇപ്പോൾ നമുക്ക് GIS എന്നൊരു പ്ലാറ്റ്ഫോമിലോട്ട് കൺവേർട്ട് ആയിക്കൊണ്ടിരിക്കുന്നതാണ്. അപ്പൊ ഇതിന് ഒരുപാട് ബെനിഫിറ്റ്സും കാര്യങ്ങളും വേൾഡ് റെക്കഗ്നൈസ് ചെയ്ത് കഴിഞ്ഞു. കാര്യം നമുക്ക് എന്തെല്ലാം കാര്യങ്ങൾ നമുക്ക് ഒരു ലൊക്കേഷണൽ ആട്രിബ്യൂട്ട് കൊടുത്ത് നമുക്ക് GIS എന്നൊരു പ്ലാറ്റ്ഫോമിൽ കൊണ്ടുവന്നു കഴിഞ്ഞാൽ നമുക്ക് മണി, ടൈം, അങ്ങനെ എല്ലാം നമുക്ക് ടൈം ഫോർ എ പ്രോജക്ട്, ടൈം കൺസ്യൂംഡ് ഫോർ എ പ്രോജക്ട്, മണി കൺസ്യൂംഡ് ഫോർ എ പ്രോജക്ട്, അതേപോലെ കൂടുതൽ പെർസ്പെക്റ്റീവ് വ്യൂ ഫോർ മേക്കിംഗ് എ ഡിസിഷൻ. അങ്ങനെ ഒരുപാട് ഗുണങ്ങൾ നമുക്ക് ഈ ഒരു ടെക്നോളജിയിലൂടെ ഉണ്ട്. അപ്പൊ വാട്ട് ഈസ് റിമോട്ട് സെൻസിങ് ആൻഡ് വാട്ട് ഈസ് GIS എന്നൊരു ടോപ്പിക്കാണ് നമ്മൾ ഇവിടെ അഡ്രസ് ചെയ്യാൻ പോകുന്നത്. സോ ബേസിക്കലി when we talk about GIS, if we are not talking about remote sensing, it will be an unfair thing to do. So what is remote sensing? So remote sensing is basically a collection of information about an object or phenomena without being in direct physical contact with it. It is simply collection of an information. It can be about an object, about a building, about a road, about an office, or it can be about a phenomena like temperature, weather, pressure, rainfall phenomena. We are collecting the information without being into physical contact with it. So from a far away distance or from a nearby source, we are collecting the information. Like earthquake. When earthquake happens, we cannot go to the location and measure the whatever Richter scale it happened. So we use some equipments for collecting the data and analyzing it at how much scale did this earthquake occur. So it is something like that. Or during in some other disaster, we have to plan a mitigation measure. So we cannot approach the disastrous area and do the mitigation measure or plan the medical measures as such. So we need a database and information about what occurred there. So remotely we are collecting this data. So such technology is called remote sensing. And remote sensing is a technology for sampling electromagnetic radiation to acquire and interpret non-immediate geospatial data from which to extract information about maybe a feature, maybe an object or classes on Earth's land, surface, ocean and atmosphere. So what we operate here is something called as electromagnetic radiation. It is actually our light. Okay, it's a light source, so it propagates in an electromagnetic radiation base, something like basic physics. So we use these light sources, maybe from the sun, or maybe what objects are emitting, or maybe some physical device which used to propagate this electromagnetic radiation. So we will use these electromagnetic radiations to know what all are happening and to study the things like object or classes, as I mentioned before, to study the phenomena or whatever occurred there or what is present there. So we are using these electromagnetic radiations for remote sensing purposes. So remote sensing, through remote sensing we acquire a lot of data. So this data can be anything. So it can be a force distribution, it can be a sound wave, or it can be an electromagnetic energy distribution. It can be anything. So what is happening in remote sensing actually? So there are two things happening in remote sensing. The one thing is data acquisition and the other is data analysis. Both are equally important. Actually, data acquisition, we plan using remote sensing science technologies, and data analysis, we are doing it in GIS platform. So the acquired data from remote sensing is handled and taken care of in GIS platform, Geographic Information System platform, to make it into a people analyzable form so that the stakeholders can take good decisions. So it will help them in decision making. So what is happening? There will be an energy source of illumination. The energy sources can be the sun or some local objects which have sensors which have been modeled for emitting energies. Okay, so it can be two ways. I'll come into it later. So there will be an energy source. So this energy will be propagating. So let me say light energy. This light energy will be propagated through the atmosphere. Okay, so there will be a lot of atmospheric interventions, and this energy which is propagated through the atmosphere will be hitting the object or the target or the phenomena or the feature. Okay, and after hitting the target, it will get reflected. The object will absorb some energy. Some will get transmitted to different locations. Okay, so whatever being reflected again is absorbed by it propagates through the atmosphere, and it reaches the sensor, which is the receiver, which collects this data. Okay, so the energy which is being reflected from this object, targeted object, will be collected in the sensor, and this sensor will transfer the data into a proper storage area, and from this storage area we retrieve the data for further analysis and interpretation. So that part is done actually using the GIS. So these are mutually complementary things. Like through remote sensing, we collect the data and it is transferred to a device and to a computer platform, from where we will analyze all the stuffs and come to a meaningful meaningful outputs or meaningful information for various decision making. So for this we have to first understand what the electromagnetic spectrum. So actually the energy which is transmitted, okay, the energy, light energy which is transmitted has many, like it is different, like it is defined by different wavelengths. So it is constituted in electromagnetic spectrum. So like I would mention one of the powerful remote sensing system in the world, in the living world, is our human eyes. Actually, our human eyes acts as a remote sensing sensor, which will sense the electromagnetic spectrum in the visible spectra. So it is like visible spectra constituted from 0.4 micrometer to in wavelength, 0.4 micrometer wavelength to 0.7 micrometer wavelength. So 0.4 to 0.5 will be blue region, 0.5 to 0.6 will be green, and 0.5 to 0.6 to 0.7 will be red region. So this light energy is detected by our eyes, and our eyes acts as a remote sensing center, and it is sent to our brain for meaningful conversion of analysis of the data which the eyes recorded, and conversion of the data of it into meaningful information. So our eyes acts as a remote sensing system, and our brain will act as a GIS system. So that is basically how everything works here. So like talking about electromagnetic spectrum, there is a like our visible spectrum, as I mentioned, ranges from 0.4 to 0.7. Then infrared, it is 0.7 to 1.4. Then there is like thermal. Infrared is again divided into short wave infrared, mid wave infrared, and thermal infrared. Again, we have higher wavelength bands called microwave bands. Then we have radio and television bands, which are very in kilometers. The wavelength of those are in kilometers. Okay, the microwave bands ranges from 1 millimeter to 1 meter. So what is the significance of this wavelengths? Okay, so actually you can see a graph here. It relates the wavelength and the atmospheric transmission. So during the remote sensing, what we are worried is like how much energy propagated from the source is reaching the object, and also how much energy is recorded by the sensor. So when we check the electromagnetic spectrum, we can see that entire electromagnetic spectrum is not completely transmissive of the energy from the source. So by analyzing this graph, we can see that visible region of the spectrum is almost 100% transmissive, and infrared region is also somewhat transmissive, and microwave bands is also 100% transmissive. So our general remote sensing system, which are used for imaging purpose and all, will work in this visible and also infrared region. And for weather forecasting system and all can work in microwave bands for various reasons. So this is the basic science from propagation of energy from the source to the target. So while designing this kind of systems, we at first we decide what are the applications that we want to address by getting the information, and after defining the applications, we search for the wavelengths at which we can attain this application. So we will find the wavelength suitable for this application, and we will design the sensor. That is how things works in remote sensing. So as I talk about propagation of energy from the source to the target, there are two kinds of system happening. So one is the active system and one is the passive system. So first I will talk about passive system. So passive system is generally, there will not be a source of emittance of radiation. So the source for the energy transmission will be our sun, or the second source will be all the objects which are above absolute zero, that is minus 273 Kelvin, emits its own energy in the thermal spectra of radiation. So what we do is we will design a sensor which can collect these kind of wavelengths, which can detect these wavelengths. Passive remote sensing generally works in the visible region of spectrum, where energy from the sun is reflected from the object, and this energy is collected in the sensor and detected and transferred to a computer system for various applications. Some of the sensors are Landsat, Aster, QuickBoard, and ICROS. These are some satellite sensors which are used for remote sensing purposes. And our own Earth systems are there, which is LIST-3. Our own Indian systems are there, which is LIST-3 and Cartosat systems. And about active remote sensing, active sensors will emit the radiation from itself and collect back the reflected radiation from the object. So whatever radiation it is emitting is received back by the active sensors. So some of the active sensors are LiDAR, which is one of the booming topic in the world, which is light detection and ranging, which is now used as one of the most prominent technology in urban mapping, 3D city modeling, survey techniques and all. And the other system is radar system. So talking about the platforms. So while remote sensing, actually we have to define different platforms. So based on our application, we have to find the platform for remote sensing data collection. One of the platform is ground-based platform. The other one will be airborne, and the other one will be spaceborne. So ground-based, actually, many systems like Tata Station, what we are using now. It's one of the ground-based remote sensing technology, actually. And LiDAR tech. LiDAR tech can be used as ground-based and also airborne techniques. So there are many hybrid technologies which uses different platforms. And now one of the important coming up or booming sector is drone technology. So drone is one of the remote sensing technology which uses airborne platforms. So we will fly a drone in 200 meter or 500 meter above mean sea level altitude, and we will collect the data for our needs. What is the purpose of this data collection is that we can get well-defined high resolution data for our application purposes. So, and the other thing is spaceborne technology, as you know, the satellite technology. The satellite technology generally operates in the altitude from 600 kilometers to 1,000 kilometers. And there are also other satellites which ranges up to 36,000 kilometers altitude. So mainly remote sensing satellites are concerned, mainly they operate in the range of 600 kilometers to 1,000 kilometer range above in Earth's atmosphere. So, so we came with the active or passive remote sensing technique. Then we are designing the platform. Will it be ground? Will it be airborne? Or will it be spaceborne? So now the third thing is, and the most important thing is, sensor and platform characteristics. So while data collection, the refineness of the data or the accuracy of the data is defined by these characteristics, actually. So these characteristics are very important while modeling a sensor. There are certain trade-off. Actually, we cannot entirely go for high definition system. There are four things. Like there is spectral resolution, there is radiometric resolution, there is spatial resolution, and there is also temporal resolution. So basically, we think that we can go for higher spectral resolution, higher radiometric resolution, higher spatial resolution, and higher temporal resolution, which will give you high definition data. So basically, it doesn't happen like that. There are certain trade-offs. It is decided according to the applications at which you are designing the sensor. So one thing is spectral resolution. So spectral resolution, as I talked about electromagnetic spectra, which part of the spectra are you using for your data collection purpose? Are you using your microwave part of sensor? Are you using your infrared part of the sensor? Are you using the visible part of the spectra? These kinds of decision constitutes the spectral resolution. And the other thing is how much bandwidth, how much bandwidth are you defining for each spectra? So when you reduce the bandwidth, the data will be more finer. And when you increase the bandwidth, the data will be more coarse. But the thing is, when you go with a lower spectral resolution, like hyperspectral data are there, which defines hundreds, more than hundreds, 200s of spectra. But the problem we will face is that the bulkiness of data, and also it will be very tedious to handle this data. That is one of the problem of spectral resolution. So what we do is, according to our application, according to what are the information data we require, according to that we will design the spectral parameter of the sensor. And the second one is radiometric resolution. So what is radiometric resolution? Smallest differences in energy that is measured. Okay, so you have heard about computer system with 8-bit, 16-bit, 64-bit configurations. So what is that? So actually, in remote sensing system, this data are recorded in various grayscales. So it ranges from 1 to 200 to thousands to 10,000 of grayscales. But the thing is, if you go for a higher radiometric data, the data will become very bulky, so that it cannot be handled in a normal computer system. So you will be requiring a supercomputer to perform very high operations with very high radiometric resolution. So if you are going with a 8-bit data, suppose you are going with a 8-bit data radiometric resolution, you will be having 255 values of grayscale. So I will show you here. You have a 8-bit data and you have a 1-bit data. Okay. So 8-bit data, there will be 255 levels of grayscales. That is 2 raised to 8 minus 1. 2 raised to 8 minus 1, that will give you 255. So in 1-bit data, there will be only black and white grayscale. So you can see that 8-bit data is more well defined than the 1-bit data. Okay, so but the problem we face, we'll get a more finer data using high radiometric resolution. So but the problem we'll face is, if you increase the radiometric resolution, the data will get more bulkier and it will be very tedious in handling the data. So we'll design the sensor according to the requirement. According to what require, if we need more finer data, we'll go for a higher radiometric resolution. But if we need less finer data, our purpose is sort out with the less finer data, we'll go with the low radiometric resolution. And what is spatial resolution? So it is one of other important features. So basically, satellite data are basically classified or approached through spatial resolution. So it is a smallest unit area which we can measure from a data. Okay, so see, you can see a Landsat data and you can see a ICONOS data. So what differs in this data is that Landsat data is 30-meter resolution. Okay, and ICONOS data is 1-meter resolution data. So from this itself, you can see that ICONOS data have more clarity and more finer result, but Landsat data is much bit coarser. So these kind of decisions are very important in remote sensing. So what kind of spectral spatial resolution data are we using? So if we have a large area, so what the problem is, if we can go for a higher resolution data, spatial resolution data, but the field of view will be very less. So small areas only we can initially collect data with these higher resolution sensors, but using lower resolutions, spatial resolution sensors, the field of view will be very high. And the data also, again, the problem of bulkiness of data will arise in this also. And talking about temporal resolution. So temporal resolution is the time between two successive image acquisition over the same area. So see, if we are going for rainfall data, again, morning like 10 o'clock we are getting a rainfall update, and again 2 o'clock we are getting a rainfall update. So it will be defined in hour. Other thing, if you are going for a remote sensing image capture, maybe after 14 days, we are getting an image after 14 days. So this temporal resolution will be 14 days. So according to the applications, we can come into conclusion. So for weather forecasting, we need much finer temporal resolution. But for imagery, actually there are no drastic change happening day by day to a land parcel. There are changes happening, but there is no drastic change. So we'll come to a conclusion. Okay, from this many days or these months, we can collect the images of this area. So the temporal resolution will be lower as the number of the period for revisit increases. Okay, this is basically what happens in a remote sensing part. So we'll decide if it is an active remote sensing or passive remote sensing, and then we will go for the platforms, whether it is a ground based, whether it is a airborne, whether it is spaceborne. Then we will go for the sensor platform characteristics, whether it is spectral resolution, radiometric resolution, spatial resolution, and revisit time. So this is the basic remote sensing part. And now we'll move to the GIS part, which we'll be talking about more in the coming day session also. So what is GIS? So GIS is Geographical Information System or Geospatial Information System. So what we are talking here about is an information system. Okay, geographic data plus an information system. So what is geographic data? Geographic data is data something will have a geographic coordinate. Okay, so whatever it may be a person. So it may be a building, it may be a road, or it may be a feature, phenomena, something else, which will have a geographic attribute. The geographic attribute meaning a latitude or longitude which points out the location of the data, okay, or the location of the object. So this data we are bringing into a computer information system for analyzing and for further classification of data or whatever else. So this is generally a GIS, a computer system which can handle a geographic reference data with like rainfall. Okay, like if Kerala will experience what of rainfall in the coming days. So the information system is the rainfall and the its values, and the geographic part is Kerala, but where it is happening. So that is basically what GIS is about. So a broadly accepted definition for GIS was given by United States Geological Society. So a GIS is a computer-based system which is capable of capturing, storing, analyzing, and displaying geographically referenced information. So what is what is the importance of GIS? So the British government in 1988 stated that the invention of the microscope and telescope were to science, the computer to economics, and the printing press to information dissemination. It is the biggest step forward in handling of geographic information since the invention of map. So before we have dealt with the topographic map, topo sheets. So now actually the system has completely changed. We are converting this topo sheet, the data is available in topo sheet, to the geographical information systems. And we are also bringing other perspective. What all locational perspective we can bring into this area, we are bringing, so that it will give more insight about the decision making process, and it will be more helpful and more easier task for proper decision making. So what prompted the development of GIS? Actually, many things. These are the few things which prompted the development of GIS, like proliferation of data. So after over the last 2 decades, there have been a surge in development of data gathering methodologies, plus the increasing ability to electronically transfer the data. So basically, what the problem which we faced before was how to handle this kind of data. Okay, these data are bulkier, so we need a high before we needed a high processing systems like supercomputer like systems for handling these kind of data, but the system has changed completely in the last 2 decades. Actually, like our data capabilities, data mining technologies, and computer systems has developed in a large scale that even a person with a little knowledge of handling computer is capable of dealing with this kind of data right now. You don't need a high performing system for dealing GIS. For basic, yes, you need a high performance system. If you're going for a high like lidar system or something very high definition data, yes, you need a high performing system. But if you are using some basic GIS data for some basic operations, you just need a 2 GB RAM or 4 GB RAM system with like a proper visual, with a proper graphics card and a visual system. And the next thing is reduction of computer cost and increase of computer capacities. So that actually everybody knows, like our computer cost has came down to a very greater extent, and also our computing capacities, the knowledge-driven computing capacity, the machine language, and the artificial intelligence has gained a greater momentum in the past few years. So this also had led to the development of geographical information system and integration of parallel developments. Okay. So when we talk about GIS, we are just not only concerned about the geographical data. We can convert the different environment, different data from different environments to the GIS platform. So how we do this? So if we have a CAD drawing, okay, if we have a CAD drawing and we know the geographical attributes of that CAD drawing, we can bring this into GIS by attributing the geographical information to this CAD data. So this actually has developed into a larger scale, and now it is something called building information model, where all the information about your construction, whatever it is, will come into a different system with the geographic information also. So actually what you are visualizing is a real world scenario. So we are bringing the real world scenario into your computer system, and you are making decisions according to that. You are monitoring it, you are inspecting it, you are making like day-to-day decisions using this technology. So that is something called integration of parallel developments. So it can be digital cartography, it can be surveying, and very interesting field called geodesy. So what is geodesy? Geodesy, like you all use this technology in a day-to-day manner. Actually, your Google Maps works in these concepts. Your navigation system, the GPS system, which will give you more insight about the location or the place you want to go, or the minimum time you take to reach these kind of these places. So that technology is called geodesy, which is like locational inputs, which will give you locational insights, and increasing demand of GIS output in public and as well as private sector. Now everything has shifted into GIS platforms. So if you are going for a road design alignment, you primarily it was driven by going into field and collecting data, but now it has changed a little. Yes, there is going into field, collecting data, everything, but you can attribute these real world data into a simple computer system. That is what GIS is about. You will collect this data and you will store it in the GIS platform. So you will model a real world system itself. Real world system you are modeling into your computer. So that is what prompted the development of GIS. Now even public and private sector, everybody is like identifying the potential of GIS, and they are in many sectors. They are converting all their databases. Now their databases are driven by GIS databases. Okay. So now we talked about data, and it's important that we convert this data into a meaningful information. Otherwise, these data are of no use. So whatever data we have to convert it into a meaningful information. So, what is information? So, information is something, it's an answer to a question based on raw data. So, like if you are attributing your name in a platform and you are giving a geographic coordinate yourself, but that doesn't make sense, right? You need more information. So, whatever you can give your name, you can give your age, you can give your height, you can give your weight, your address, something like that. So how much more attributes you provide to the data, it will become more meaningful information. Something like that. So if you go for a survey, you are collecting your levels. Okay, so these levels as individual, there is no meaning. But when you combine all data, you will give a terrain model. So when you bring this level information to a GIS platform, you will get a real world terrain model. So if you know the orthometric height, you can also convert this level data into the according to like in mean sea level perspective also. So you can model your roads or buildings or something else with the information about the area, like about the area where it is situated, or how much altitude it is from mean sea level, like that information. So this is basically the concept. So you have one data, you have many sample sites of soil sampling, maybe a soil sampling. So you have many sample sites. You can see 1, 2, 3, 4 to 10 sites, and you have measurements. Okay, so sample 1 have 10% sand, 85% clay, and 5% silt. Sample 2 have 8% sand, 86% clay, and 6% silt. So you have these kinds of information with you. So these two things separately won't make any sense. Okay, so you can just individually point out at each samples like that. 1, 2, 3. Like sample 1 have these attributes, sample 2 have these attributes. But when you bring into the GIS platform and model it, what happens is that in the real world, how these samples are distributed. So this much area constituted of clay, this much area constitutes of sand, this much sandy clay, sandy loam, like. So what is the use of it? So you are getting a broader perspective. So your perspective is changing. Actually, the first your data was constrained into a single point from where the sample was collected. Okay, but when you combine all this data and bring it into a geographical perspective, what changes is that your perspective will become broader. So how these samples or this distribution of various soil samples are spread across a area of interest. That is what these geographical informations bring, which that basically a broader perspective of various data. So basically, what is an information system that I mentioned before? An information system can be a very simple thing, such as a telephone directory, maybe your ID card. Your ID card can be an information system when we bring it into a computer system. So in the digital environment, we use softwares to create complex information systems. So there are many softwares. Like one of the thing is like Excel. Microsoft Excel, Microsoft Word, Microsoft Access. These kind of things we use in a day-to-day basis. So these things are used to bring all the information together and to model a complex information system. So what is a knowledge base for GIS? So GIS is like, it is not an individual system. It is complemented by many factors. So one thing is a computer science or management information system. It's called MIS. So which includes graphics, visualization, a proper database, a system administration, and security. Okay, those are computer terminologies. So you need a proper graphic system for visualization. You need that is very important, is you need a proper database management system. So if one or two data, it is easy to maintain and such, but daily you are collecting data, or throughout a year you are collecting data, it is very bulky. The data will become very bulky, that managing that will be a tedious process or a confusing process. So you need a well-defined database management system for handling these kind of data. Then you need system administration for proper management, and you also need a proper security system. Actually, like if you are going for classified data, you cannot store as such in as we store a movie or a music, laptop or computer system. So you need proper security system for guiding or for storing this kind of data. So that is the computer science part. Then we will come to the geography and related systems. So every data which we introduce to the GIS system, we need proper geography. So it can be a cartography, it can be geodesy, it can be photogrammetry, landforms, or spatial statistics. Yeah. So it can be a map and geodesy. Geodesy, as I mentioned before, it is the basic locational perspective. So through navigational satellites, through GPS, GNSS systems, we find the locational attribute and we'll input this attribute to the data and we'll bring it to the GIS domain. And another one thing is photogrammetry. Photogrammetry is also an important sector which is booming right now, drone. The images we use for we capture through drone technology, which can be converted into meaningful information, a survey graded information through the technology called photogrammetry. So, what is the main benefit of using photogrammetry? The main benefit is that actually, if you are taking a total station and you are going the entire, you are walking and covering the entire area, and you are collecting results. What if we can do the same thing? You can collect the levels, you can collect the details of in a more finer manner using a drone. It is more time saving, it is less tedious, and also what happens is it is cost friendly also. When you are going for a broader perspective, it is cost friendly also. That is photogrammetry technology. And what all landforms and land parcels, land use, land covers, which are available. Then it is about spatial statistics. Spatial statistics is something will relate this geographical data to math value, something like population density, something like rainfall intensity. These all are statistics. So, and also the land parcels. So this area is covered with 50 kilometers square of forest area, means that is the statistics of that land use, land cover area. And your city is your urbanized area is this much kilometer square. That means a spatial statistics which you can use for many applications. And what are the application areas? So talking about application area of GIS, it has n number of applications. So some of the application which I like to point out is public administrative applications, planning, geology, mineral exploration, forestry, site selection, marketing, civil engineering, criminal justice, and surveying. So there are n number of applications in which we can use GIS. So relation between a GIS and computer system. So how is this GIS related to a computer system? So as I mentioned before, you should have a well-defined database management system. That is the basic thing you have to hold before modeling a GIS system. So if your database management system is good, then that much good will be your GIS system, and the rest of the things which will be determined by your data and your applications. But initially, the correctness or the fineness of your GIS system will be determined by proper database management system. And what all things can be inclined to this GIS system? You can incline CAD system, you can bring an image processing system, you can bring a statistical program, n number of systems you can relate with the GIS environment. So as I mentioned before, CAD system, how we can bring this CAD system, this road alignment. If you bring the road alignment to the geographic information system, what you are getting is a real world picture of what happens if we bring a road to this area. You can get a real world system in your front. So image processing, there are many perspective at which you can approach the image processing technique. So basically you can classify different satellite images or drone images. We can classify, we can 3D model the data that we acquire through photogrammetry, or that data LiDAR, some data is called LiDAR data, which we can convert it into various 3D modeling, which will in fact lead into 3D city modeling and such kind of activities. And statistical problem, like I mentioned you about the weather patterns, the weather data. We saw different cyclone hitting Kerala, right? Like a few months back, right? So what is happening actually? Actually, what is happening was you will bring the satellite images or videos to the computer system, to the GIS system, and you are bringing the statistical programs like the intensity of the cyclone, the direction of the wind, like how much time it will take the cyclone to move from a particular location, or how much distance will it comes near the shore. So like such kind of statistical program we bring into GIS system so that we can get higher perspectives. So what are the basic components of GIS? So there are mainly 5 components. One is the hardware component, basically your computer. Okay. Then other important thing is software component. So these software components provide the functions and tool you need to store, analyze, and display geographic information. So you need a proper software according to the application at which you are using this data. So if you are using weather data, you need some data code which can handle some software which can handle weather data. If you are using for civil engineering purpose, you need some software which can do civil engineering operations. So mainly used GIS data right now is ArcGIS, which is a licensed software. And but the other beautiful software which is available as open source, you do not need a license, is QGIS. What is the beauty of QGIS is you can do all the activities that you do in ArcGIS, and also you can model your according to your knowledge, you can model a tool, and also you can introduce to the QGIS community. It is a fastly growing community. So QGIS is one of the important softwares which is used for GIS today. And also there are certain image processing softwares called LDAS Imagine, and there are many software which are oriented to survey systems like Leica, like Trimper. These equipments also use a certain GIS system to model their survey data. And the third thing is data. So what is the data? The GIS data basically will be a geographical data which will have some tabular data which gives an input towards what kind of attributes are attributed to this particular object or phenomenon. So it is a data-driven sector, right? You need proper data for deriving proper information. And another thing is people. Okay, there will be people who will be using this GIS. There will be people who will be modeling this sensor part. There will be people who will be working in collecting and storing this kind of data. There will be people who will change this data into meaningful information using the GIS environment. And there will be people who will be using GIS for making decision. So whatever data you have accumulated and converted in according to your needs, that will be done by a proper person who knows to use a GIS. But the other beautiful part of GIS is that these kind of informations can be handled in GIS platform with basic GIS environment. So the end users like is a survey engineer or a civil engineer who is interested in road construction and something like that. Those people can handle this data in GIS environments. You just need to have a basic information about this data. You just don't go okay, how will we collect this? How will we manipulate this data? How will we collect this data? Such worries will not be there. You will be given the information from GIS data, and you can use the GIS platform for making various decisions for your decision making task. And the next important thing is methods. So you need a design plan or a business rule to extract information from this data. So these are the main 5 components which will drive the GIS system. So what I told was hardware, which can be a GPS handset, which can be digitized in tablets, which can be a plotter and print anything. And software, as I informed, it can be ArcGIS, MapInfo, QGIS, etc. ArcGIS and MapInfo are license one, but commercial softwares, but QGIS is an open source software. So what are the there are many benefits of GIS. So what are the top 5 benefits of GIS? So it is cost saving and more efficient, and it will give you a broader perspective which will help you in better decision making, and it will also help in improved communication. So mainly what the what different multidisciplinary sector face like the problem faced by the multidisciplinary sector is that a person from a different background finds it difficult to convey their data or convey the information to a person with another background. So what GIS brings is that a person from a different discipline can convert a user-friendly product from the acquired data and communicate easily to the person from a different domain. That is how GIS things work. So what if a GIS data specialist collects a LiDAR data, which is then so when we give a LiDAR data to a common person who is a civil engineer who uses other CAD softwares for modeling, it will be very tedious task for him to identify make sense of this LiDAR data. But what if the person who is handling the GIS converts this LiDAR data to a 3D model and to take the output in a CAD version and give it to a person who is using CAD platform? So he is communicating his version of tech in the other person's language. So that is how it improves communication. And obviously better record keeping. So previously we used to take a book and go to field, and we'll write down different field inferences, and after the project it is lost. The field inferences are lost. So what GIS does is, first we'll collect the locational attribute. That is, you'll go with your mobile or a GPS receiver, and you will collect the geographical area attribute. Then what we do is, we in different attributes we will input the inferences in this geographical area. Maybe it is a road, it is a building, whatever it is. We'll input this and we'll manage it in a digital platform so that it will be there until eternity if we have a proper database management system, and a person can easily find the data and retrieve the data through small computer queries. So the record keeping will be more easier, and it's also more flexible according to this perspective. And finally, managing data geographically. So managing a data geographically, what does it gives to us? It will give a broader perspective, a real world perspective for managing such kind of data. So what is layer concept? So layer concept, according there will be different layers. Like one will be a cadastry, one will be a land parcel detail, one will be availability of schools, availability of hospitals, like that. So these are different layers. So what if you can bring all these layers into a compact environment and overlay each and make a decision? So that is the beauty of GIS. If you are going to a new place and you are willing to find a new house to accommodate. So basically, what we'll be searching is your nearby markets or nearby hospital, nearby schools, such kind of things. So these are different layers. So nearby markets will be one layer, nearby schools will be another layer, nearby hospitals will be another layer. So you in GIS, you are not dealing with this layer differently. You are bringing all the layers together, and you will perform an overlay actions. So you will lay each and every layers together, and you will make a decision. So your decision making will be more easier and also more accurate in these kind of operations. So what GIS generally do? So what GIS generally does is, it tells us what exists at a particular location, and where can specific features can be found, and trends, or what has changed over time, and what spatial patterns exist, and also the modeling perspective. So there are 4 M's that we generally use in GIS, that is measure, map, monitor, and model. So GIS as a means of integrating spatial data acquired at different scale, time, and format. So we'll bring whatever data is acquired in a specific geographical domain, and we will measure, map, monitor, and model this kind of data. So finally, like what is done in GIS? So at first we'll input a spatial data. So that is basically a data entry process, which will have a data editing phenomena, and there will be a geometric transformation and projection and pre-projection, which we'll be talking much about in the third section, coordinate system. So that is something very important. You should have a whenever we are talking about GIS, we should have a basic understanding about the geography also. So that is what at first happens: input of the data, then attribute data management. So you will enter the data and you will verify the data if it is correct or not, and you will do a specific database management, and you will do the attribute data manipulation. For example, if you are entering your age in 2020, it will change at 2021, you will be 1 year older, so you have to update that data. So such kind of updations come in database management. Then data display. So data display is how we convey our information to different person, or how we understand what we have collected. So that is something 2 things happens is, one is cartographic simplification and another one is map design. So whatever data we have collected, we should be able to read that data. So for proper reading or understanding of data, we should be doing a proper data display. So we should be giving certain symbologies or certain map designs for a more understanding of data. Then what we does is data exploration. Data exploration is like attribute data query. So if you want to retrieve some information from your data, you will perform a simple query. So whatever attributes are available in data, you can design a simple query and retrieve the information. Then spatial data queries are there, and geographic visualizations are there. Geographic visualization generally means you will visualize these things in a real world platform. So then there is the important thing, data analysis. So you will come up with a proper results during this process. So you have to get the data, define the data, update the data, and you have to do proper analysis. So these things, vector data analysis and raster data analysis, will be talking more about in the tomorrow's sessions. These are the main 2 data models in GIS. Then you can do terrain mapping and viewshed and watershed analysis, spatial interpolations, geocoding and dynamic segmentation, and path analysis and network analysis. This analysis, network analysis is now gaining a lot of momentum in like transportation sector. Previously, from the previous perspectives, now we use GIS platform to perform this kind of network application analysis. Then we have proper results. Then with these results, we'll go for GIS model. There will be binary models, there will be index models, there will be regression models, and there will also machine language and artificial intelligence driven process models. So something like that. These models will give you the proper output which you need, which will help you in proper decision making. So I think I have touched briefly on the geographic information like operation parts. And what are the data sources? So one thing will be existing map, your topo sheets. Another thing will be aerial photographs with your drone or your airplane photographies. Then your satellite imageries, field surveys, and various other sources. These all data sources will make it into a digital input data and we'll apply it into GIS. So what ultimately is happening is, you will collect the data, you will perform the operations, and we will change it into information, and based on the evidences you acquire and your knowledge, you will convert it into proper wisdom through proper decision making. So I think we can stop it for now for today, and thank you very much for listening. And if you have any doubt, you can please ask.
Thank you, Arun. So those who have doubt, please raise your hands. I'll unmute you one by one, or else you can type in the question in the chat box or question. ഡൗട്ട് ഉള്ളവർക്ക് ഹാൻഡ് റൈസ് ചെയ്യാം. സ്ക്രീനിന്റെ താഴെയായിട്ട് ഹാൻഡ് റൈസിനുള്ള ഓപ്ഷൻ ഉണ്ട്. ഹാൻഡ് റൈസ് ചെയ്യുന്നതനുസരിച്ച് അൺമ്യൂട്ട് ചെയ്ത് തരുന്നതായിരിക്കും. അൺമ്യൂട്ട് ചെയ്ത് ഡയറക്റ്റ്ലി ക്വസ്റ്റ്യൻ ചോദിക്കാവുന്നതാണ്. ദയവായി ക്വസ്റ്റ്യൻസ് ഉള്ളവർ ഹാൻഡ് റൈസ് ചെയ്യുക. സ്ക്രീനിന്റെ ബോട്ടം ഹാൻഡ് റൈസ് എന്നുള്ള ഓപ്ഷൻ ഉണ്ട്. ഹാൻഡ് റൈസ് ചെയ്താൽ അൺമ്യൂട്ട് ചെയ്ത് ഡയറക്റ്റ്ലി ക്വസ്റ്റ്യൻ ചോദിക്കാം. അതല്ലെങ്കിൽ ക്വസ്റ്റ്യൻസിലോ ചാറ്റിലോ നിങ്ങൾക്ക് മെസ്സേജ് ആയും ചോദിക്കാം. ഡോക്ടർ രമേശൻ ഒരു ക്വസ്റ്റ്യൻ ഇട്ടുണ്ട്. ക്വസ്റ്റ്യൻ അല്ല, ഒരു അപ്രിസിയേഷൻ നോട്ടാണ്. താങ്ക്സ് ഫോർ ദ നൈസ് ക്ലാസ് ഓൺ ഇൻട്രൊഡക്ഷൻ ടു GIS ആൻഡ് RS. താങ്ക് യു സർ, താങ്ക് യു രമേശൻ സർ ഫോർ ദിസ് കമന്റ്. ഓക്കെ, ഐ തിങ്ക് അങ്ങനെയാണെങ്കിൽ നമുക്ക് ഇന്നത്തെ ഈ ഒരു സെഷൻ വൈൻഡപ്പ് ചെയ്യാം. നാളെ ഇതിന്റെ ഒരു കണ്ടിന്യൂഷൻ ആയിട്ട് നെക്സ്റ്റ് 4 days 10ാം തീയതി വരെ ഈ ഒരു സെഷൻ കണ്ടിന്യൂ ചെയ്യും. സെയിം രജിസ്ട്രേഷൻ ലിങ്ക് ആണ്. സെയിം ഇനി ഇതിനായിട്ട് അഡീഷണൽ ആയിട്ട് രജിസ്റ്റർ ചെയ്യേണ്ട, സെയിം ലോഗിൻ ഡീറ്റെയിൽസ് വെച്ചിട്ട് തന്നെ നിങ്ങൾക്ക് നാളത്തെ പ്രോഗ്രാം അറ്റൻഡ് ചെയ്യാൻ പറ്റും. എന്തെങ്കിലും ടെക്നിക്കൽ ഡിഫിക്കൽട്ടീസ് ഉണ്ടെങ്കിൽ KHRയുമായിട്ട് ബന്ധപ്പെടുക. താങ്ക് യു ഓൾ. അരുൺ, നമുക്ക് ക്ലോസ് ചെയ്യാം.
ഓക്കെ, താങ്ക് യു.
ഓക്കെ, താങ്ക് യു ഓൾ.